location of your homing switches. This is your Z, your Y, and your X is around there, and that's the actual proximity switch. This is the terminal box on the back of the unit, and I've just used strip connectors, basically screw down strip connectors to connect the wires. You've got there's one of your inductive sensors there, so you've got the white and the black wire going into a white and black and a black wire. You've also got your stepper motors in here as well, so that's where you gain access to all that if you want to trace the wires through. Proximity switches, they're actually located on, again, some nice quite long wires on the original Duo. The y-axis is on this one. The one next to it is the x-axis. That's easy enough. And the z-axis is on this one. So we've got all those three. They're two wire proximity sensors. So we're just going to wire those up, and I'll show you how we do that. Should only take a couple of minutes to do that. I'm starting to think, that there might be space in this unit to leave all the original circuit boards and that. So if anybody ever wants to revert it back, I mean, all of this control stuff could all be in a box externally. Well, it's a thought anyway. The two wire inductive sensors, very easy to wire. Actually, on the Mach3 control board, there's an input for 24 volts, a DCM, which is the common ground for this side of the board, as it's isolated via these opto-isolators for all of these control signals. We simply take a 0 volt reference from DCM back to your power supply 0 volt, connect one wire from each of the two wire sensors into, I've used a terminal block here because there's 3 wires in total and there just wasn't room to put it all in this DCM socket. Then the other wire from the proximity sensors I've wired into IN1, IN2, IN3. It really is that simple. We then need to go into the Mach3 software and set up whether it's active, high or low. The Mach3 software is pretty easy to set up. If we go into config, ports and pins, input signals, so I've just ticked on the home box for Y, X and Z. You then need to tell it a port number. Now I was told it's just port 3, I don't know, but I'll put it anyway. But obviously it's important then that the pin number on the board is correct. So I've got X on 1, Y on 2 and Z on 3. Now these proximity switches are active low, so I've ticked all the active low boxes, and that seems to be the only setup I need to do in here. Another setting I did, which gives you sort of that bounce as it gets to the actual proximity switch or your end stop or whatever you want to call it. If you go to general config and look over on this side, input signal, debounce, noise rejection, if you set that value to 1000, what that'll give you, as it gets close to the proximity switch, it'll bounce back and then go back forwards again. Just seemed a nice way of doing it. We can also test the operation of the proximity sensors in the diagnostics page, and if you look at external there, you'll see 3 little yellow lights for you. And if I move the axes away, I'm just moving all the axes off the home position. And if I just take them back, as you can see, the lights come back on, show you that they're actually the proximity sensors are working. Let's do a quick test of the proximity sensors. As you can see, X, Y and Z are all set to 0, well they're at their home position at the moment. So what I'll do is, using the manual keys on the keyboard, I'll just move them all off. I'll show you that. Okay, then what I need to do is, if I now go back to the screen and in the program run it says reference all home, all I need to do is click that. And that seems to work fine. As you can see, it's now returned back to X, Y and Z at their 0 reference. I'll just show you the setup page. Config, homes and limits. So we've effectively got auto 0 checked. I'll put the speed at 100% at the moment. I mean, that could be slowed down if you want to take them home slower, but that seems to work at the moment just for testing.